video we basically discuss on the classification of the fusion welding process, and then we discuss on the classification of the solid state welding process. So this is basically the classification of the fusion welding process, and this is basically the classification of the solid state welding process. Then a special welding process like underwater welding, brazing, soldering, and adhesive joining process. We talk all of this the one by one. So first one is a fusion welding process. So here we have a TIG welding, MIG welding, plasma arc welding, electron beam welding, the submerged arc welding process, the thermite welding. It is a very important. It is like a portable the welding technique, and a gas welding, and which is also known as a oxy-fuel gas welding process. Then a electro slag welding process. So if I first talk about the TIG welding, then that is known as a tungsten inert gas welding process. I talk about the TIG welding, so this is known as a tungsten inert gas welding process. The inert, then the gas. So we basically use the tungsten as an electrode, then an inert and a gas, inert gas. The function of the inert gas, and what are the inert gas, and what is inert gas. So here we basically use the tungsten electrode definitely, but that is the non-consumable tungsten electrode, which is basically the previous video we basically discussed on what is the non-consumable tungsten electrode. The main function of the tungsten electrode is that it just produces the arc. Okay, so now the function of the inert gas. So when the tungsten, by the help of the tungsten electrode, when we generate the arc, then this is basically the arc. When the arc will be the form, this arc is further protect by the inert gas. Okay, the protect by the inert gas. Protect from what? The protect from the external environment, so that we get the very precious, the very high quality welding is produced, so that very high quality welding is performed. Okay, so this is the main purpose of the inert gas. So what are the inert gas? The inert gas, like we have in an inert gas, we have argon, helium, and hydrogen. So we mainly use the helium gas in as an inert gas because the less in price. Simultaneously we also use the argon plus hydrogen, argon plus helium. So this thing. So this is the one thing, is that the function of the inert gas, it protect the arc from the atmosphere contamination. Okay, so this is basically the one thing, it protect the arc. The second reason is that it basically compressed the arc. The arc, it is basically the inert gas basically compressed the arc. So compressed, when it compressed the arc, so the heated zone, or we can say it more precisely we can say the heat affected zone. Okay, so this is the heat affected zone. The heat affected zone is very localized. Heat affected, it is a very important term. Heat affected zone, it is a very important term. What is the heat affected zone? So this is the one heat affected zone. So only this area is not only the heat affected, but few more portion, that is a heat, that particular area is basically known as this particular area. Okay, this shaded area is known as a heat affected zone. So here what is a possibility, that there have a possibility that because of the heat, there have a possibility, so because of this all area, this shaded all area, okay, known as a heat affected zone. The main disadvantage of the heat affected zone is that the main advantage of the heat affected zone, the heat, we have to create the heat affected zone very minimum. So our main intention is that heat affected zone is a very minimum. For what? For this reason, like if the surroundings area is more heated, then there have a possibility of the properties of the metal properties should getting changed. Okay, due to the heat affected zone, due to the heat, there have a possibility that the properties of the metal should be changed. What are the properties like? So this is another big aspect. The later video we basically discuss on the properties and the interaction with the heat in a detail. So this is right now. It basically compressed, the inert gas basically compressed the arc, so that the heat affected zone we get a very less. and high quality weld is performed and gaseous defect is very less. So this is the main function of the inert gas. And the TIG electrode actually use the here we basically use the non-consumable tungsten electrode, non-consumable tungsten electrode, so that what actually happen, the mass production we basically use the TIG welding. Okay, now if I talk about the plasma arc welding, so what is the plasma arc welding? It is plasma arc welding. It is basically what here we basically use the non-consumable same electrode, that is non-consumable tungsten electrode. So this is the non-consumable tungsten electrode, and this electrode is basically create the arc. It basically produce the arc. All right, this arc is further compressed by the plasma. All right, and this plasma is further covered by the inert gas. So the main purpose is compressed arc means, you can say in this, you can actually see in this particular diagram, the heat affected zone is very localized, the form, and heat affected zone is very localized form, and because of that high quality welding is performed. All right, and as the seal, the plasma is also act as a sealing, so that the gaseous defect is very less. And the main advantage is that high quality welding is performed, the less amount of gaseous defect, the strength is very high, and the corrosion and a wide resistance property is also very good on that particular the welded area.